Here we are looking at a 2s orbital. Because it is an s orbital, it's spherically symmetric. Because it is a n equals 2 orbital, it has a nodal plane, which also needs to be spherically symmetric. It can be hard to see this nodal plane, so if we remove half of the sphere, we can see the interior, where we see the change in phase indicated by the change in color and the nodal plane that lies between these two phases. Orbitals are the things that hold electrons, and so another way to envision them is to simulate finding an electron multiple times within the orbital. If we were to look for an electron 1,000 times in this orbital, here is what we might find, with each small sphere indicating a place where we found the electron when we looked for it. As you can see, this distribution is also spherically symmetric, which is good, since we are dealing with a spherically symmetric s orbital. If we had a different orbital, we would not have spherical symmetry. Consider, for instance, if we had a p orbital. There are three options: px, py, and pz. Each of these consists of two lobes of electron density separated by a nodal plane, so that the electron density primarily runs along the x, y, or z axis, respectively. Just as with our s orbital, we can envision what we might find if we were to look for electrons 1,000 times in each of these, just as is shown here. Though these p orbitals are likely familiar looking, one thing about them is interesting. We know that electrons are held to the nucleus via Coulomb attraction. However, the nucleus is spherically symmetric, which means the potential is also spherically symmetric. So why are these p orbitals not spherically symmetric? The key is to realize that the p orbitals come from spherical harmonics. They are the resonances that are supported by spheres. And the three p orbitals together represent a sphere. Indeed, if we were to combine the electrons from px, py, and pz, we will find that we have a spherically symmetric distribution of electrons, even though this distribution is still represented by px, py, and pz orbitals.